2.2 is about subsets. So a recent Harris poll estimated that 45 million Americans, or 21% of the adult population, have at least one tattoo. So Table 2.3 has broken down these tattooed Americans by age group. The table above shows the percentage of Americans by age group with tattoos. The categories in the table divide the set of tattooed Americans into smaller sets called subsets, based on age. The age subsets can be broken into still smaller subsets. For example, tattooed Americans ages 25 to 29 can be categorized by gender, political party affiliation, race or ethnicity, or any other area of interest. This suggests numerous possible subsets of the set of Americans with tattoos. Every American in each of these subsets is also a member of the set of tattooed Americans. Situations in which all the elements of one set are also elements of another set are described by the following definition. So set A is a subset of set B, expressed as it looks like a C with a line underneath it, if every element in set A is also an element in set B. So if it's in A and it's in B, and all of them in A are in B, then it has to be a subset. So the set of all X, such that X is a tattooed American and is between the ages of 25 and 29, is a subset of all tattooed Americans. The notation A with the C slash through it, B, means that A is not a subset of B. This means that set A has an element in it that is not an element of B. So if you can find at least one element in A that is not in B, then it's not a subset. So for example, if A is 1, 2, 3 and B is 1, 2, set A cannot be a subset of B because we have a 3 in the first one, but it's not in the second one. So we can show that A is a subset of B by showing that every element of set A also occurs as an element of set B. And then we can show that A is not a subset of B by finding one element of set A that is not in set B. So let's write in the correct statement. Is a subset or is not a subset? So set A is 1, 3, 5, 7, and set B is 1, 3, 5, 7, 9, 11. So this has to be a subset because all of the elements in A are also in B. For the second one, we have the set A is a letter in the word proof. So let's write that out using roster. That means we have P, R, O, and F. And set B is the letters in roof. So A cannot be a subset of B because we have P in A and not in B. And the third one, if X is a planet of the Earth's solar system and B is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, then this is a subset because all of those planets listed in B are the planets of the solar system. So actually, these sets are equal. So in this last example, the given sets were equal, which means that every set is a subset of itself. So if A is any set, then A is a subset of A because it's obvious that every element in A would also be in A. If we know that set A is a subset of B, and we exclude the possibility of them being equal, we call this a proper subset. So it's almost the same definition as a regular subset, except they are not allowed to be the exact same sets. Then it's proper. So the difference between the symbols is subset has the line underneath, which is kind of like the or equal to part of an inequality, and a proper subset does not have it, so it cannot be equal. So if we look at set A, which is 1 and 3, and set B, which is 1, 3, 5, we can use either one, the subset or proper subset, because it's not equal, so we can do proper subset, and it's automatically a subset because every element of A is also in B. Now, if I were looking at set A is 1, 3, 5, and set B is 1, 3, 5, we can only use the subset notation because they are the exact same set, and so they are not proper. So for example number 2, we want to use either the subset, the proper subset, or both in each blank to form a true statement. So if A is a person and they live in San Francisco, and B is a person and they live in California, well, if I live in San Francisco, I definitely have to live in California. So we know we can use the subset notation, but can we use the proper subset? Well, just because I live in California does not mean I live in San Francisco. So these are not equal sets. So we can actually use both. What about for 2, 4, 6, 8 and 2, 8, 4, 6? Now these are the exact same set, so we are only allowed to use the subset notation, not the proper subset. For example 3, if we let A be the empty set and B is 1, 2, 3, 4, 5, is A a subset of B? So in order to prove it's not a subset, we have to find an element in A that's not in B. Well, the empty set has no elements. So there's nothing in A that cannot be in B. And so A is a subset of B. Since there are no elements in A, it's not possible to have an element in A that is not in B. And so the empty set is a subset of every set except itself. So for any set B, the empty set will always be a subset. The empty set is a subset of every set except itself. So for any set B, the empty set is a subset of B. And as long as B is not the empty set, then the empty set is a proper subset of B. So the number of subsets of a given set. If a set contains n elements, how many distinct subsets can be formed? So if we look at the empty set, we have 0 elements, and there's only one subset, which is the empty set itself, and so we only have one of them. If I have set A, I have one element, and I will have the original set and the empty set, which gives me 2. If I have set AB, which has 2 elements, I have the original set, I have set A, set B, and the empty set, which gives me 4. And so the number of subsets actually appear to be a power of 2. So the number of distinct subsets of a set with n elements is 2 to the n. Now because we know with proper subsets, the original set cannot be a subset, all we do is we subtract 1 to find the number of proper subsets. So let's find the number of distinct subsets and the number of distinct proper subsets for the following sets. So A, B, C, D, and E. We know that the cardinality is 5. And so for the distinct subsets, that's 2 to the 5th, which is 32. And for the proper subsets, we just do 32 minus 1, which is 31. For this set, we know that I'm going to call this set A. The cardinality is 7, and so the subsets would be 2 to the 7th, which is 128. And then for proper subsets, we just subtract 1, and so we get 127.